All right, you found the quick review to exponent rules, and I'm going to try to make this as quick as I can, but there's a lot of exponent rules, and so we'll see. Hey, remember, the exponent only goes to its base. That's a key concept. So this is like a 7 times an n squared, okay? This is a 7 times an n squared, and that's important because to misapply the exponent is what gets people in a lot of trouble. So again, the 4 only goes to the y. This is a negative 3 times an x times y times y times y times y. Why, you ask? Because that's what it is, all right? Now in this situation, it's the 2xy that is cubed. So technically what we have here is 5 times 2xy times 2xy times 2xy. Make sense? I hope it does. Don't misapply the base or you'll get yourself in trouble. Okay, everybody should know the rule when multiplying like bases, and you should be thinking, hey, when I multiply like bases, I add the exponents. X to the a times x to the b equals x to the a plus b. I add the exponents. So if you look at this one, my base is n. I have a like base. I got to add these exponents. So I have a 12 plus a negative 4. Don't forget the 1 plus a 1. N is the end of the first. Okay, so what do we end up with here? We end up with n to the 9th, right? N to the 9th would be the final solution of that, right? 12 minus 4 is 8, and 1 more is 9. Multiplying like bases. How about dividing like bases? All right, well, don't forget, when dividing like bases, and remember, all these rules are shortcuts. We go into detail in the full lesson. You subtract the exponents, right? You subtract the exponents. So in that situation, this is going to be n to the 7 minus 2. All right, that's pretty easy. That's n to the 5th, right? And again, that's just a shortcut. The full video explains that. X to the a times x to the b. Let's get to the next rule. All right, that's x to the a times b. You multiply the exponents. You multiply the exponents. All right, so when you have something like this, all right, you got to be careful now. I chose a little bit tougher one because there's more than a single base in there. So be careful. The 2 has an exponent of 1. And not only do I multiply this 2 times the 5, I've got to multiply it times this 1. So really, here's where I end up. 2 to the 1 times 2, and then n times the 5 times 2. I hope that makes sense to you. So we end up with 2 squared, which is 4n to the 10th. 4n to the 10th. Now again, let me just real quickly, isn't this 2n to the 5th times 2n to the 5th? And see how you get 4n to the 10th? I hope you see that. All right, what else? Oh, zero exponent. Do you remember that a zero exponent says it's the base divided by itself, and that's why the result is 1? Because a zero exponent says the base divided by itself. So be careful in something like this, right? This is a 4 times n to the 0, or n over n. And guess what? 4 times 1 equals 4. Be careful. This part is 1. You have 4 times 1. All right, what else? Oh, a negative exponent. Remember, the negative exponent says do x to the a in the denominator. X to the a in the denominator. A negative exponent in the numerator will make it a positive exponent in the denominator. And look at this one. A negative exponent in the denominator will be a positive exponent in the numerator. Here's the shortcut. Whenever you take a base and its exponent across the fraction bar, you change its sign. So let me do that real quickly here on our last example. Here's a negative exponent. Take it down below across the fraction bar and change the sign. Here, and by the way, I just did it, so I'll cross it out. Let's take z to the negative 4, take it across the fraction line and change its sign. Final answer, 5z to the 4th divided by n to the 7th. Hey, it's that easy. All right? Exponent rules in a flash.